Alright, in this video we're going to have a look at what's called the factor theorem now. Very similar to the remainder theorem, except we're almost going the other way around. So basically all it says is if we have a polynomial f of x and we find that p of a is equal to 0, then we can say x take a is actually a factor of p of x. So almost we're saying that if we put some number into p of x and we find that it's 0, then that number there is actually a factor of the polynomial. Let's have a look. So we're going to show that x plus 3 is a factor of 4x to the 4 plus 4x cubed, take 25x squared, take x plus 6. Okay, before we'd say we're dividing this by this linear factor, okay, and that'll give us a remainder. Well, if we do the same thing, if we divide this by this, we actually should get a factor of 0, or a remainder of 0, sorry. So let's have a look. So x plus 3, similar to what we were doing before. So a in this case is going to be minus 3, because of the positive. So a equals minus 3. So when we substitute that value in, we should get 0. So 4 times, we've got minus 3 to the 4, plus 4 minus 3 cubed, plus 25 minus 3 squared, take minus 3 plus 6. Again, brackets are your friend. Always use your brackets when you have negatives as a general rule of thumb. So that should give us 324. Minus 108 plus this one 225. Okay, two negatives make a positive, and plus 6. Okay, you could probably do it by hand, but calculator is quite easy. That gives us 0. Okay, so for this question we're showing that x plus 3 is a factor of this using our factor theorem, because when you put that number a equals 3 into that polynomial, then we get a remainder of 0. So it's indicating that that is a factor of this. So that's all the factor theorem is.